we're going to look at a problem on ALEKS that a couple students had questions about, and that was within the radical section. So I decided I was able to extend the deadline for the transformations and made it actually the same as the one for quadratics. So now you can see that that looks like a total of 12 topics. So that was 8 from transformations and 4 from quadratics, I believe. So anyway, they're both due on Sunday, so that's why they're together. So when I'm inside of here, and yours should look very similar, there should be at least 12 topics, probably less since you have been working on stuff. You might have a couple more because of those prerequisite topics. But the question that was asked had to do with the radical one. So you could see like this is from the radical objective, this is from the quadratic equation objective, and then you kind of keep going. So the question was on this, graphing the square root function, problem type 1. So the way that we're going to be doing this is looking at, it says that we want to graph the function f of x equals the square root of x minus 4. So the very first thing to remember is what the parent function looks like. And the parent function has square root of x. It's going to be at 0, 0, and then kind of shooting off, okay? We can't plug in any negative values to the square root because then that comes up with a new type of number, which is called an imaginary number, which we'll learn about later. With our transformations, we've also seen that when the minus 4 is inside the radical, you see how this little radical bar is on top of that whole x minus 4? That means that this minus 4 is directly affecting x. And so this is actually shifting the entire graph to the right 4 spaces. So just based off the transformations, we can get a few of our points. So look what it says. Plot 4 points on the graph of the function. You need the leftmost point and 3 additional points. So remember that the square root function starts at 0, 0 and then shoots off. So it has a leftmost point because we can't go into the negatives. But now because we're shifting to the right 4 spaces, that's going to be now at this point 4, 0 and then shooting off. And I know it's 4, 0 because you're thinking about what would make this inside part become 0, and that would be a positive 4. So you can plot the point by clicking on the pencil and then plotting that point 4, 0. You could also click on this little coordinate plane and identify your point in here. So you could put 4, 0 and plot the point that way. Now you need to get 3 additional points. If you don't do 3 points, it doesn't know what to graph, and it kind of tells you right here. This is going to be the thing that graphs connects the dots for you. So the next point, I know that my normal parent function would be at 0, 0 and then 1, 1. So that point 1, 1 is also going to shift to the right 4 spaces, which actually puts it at 5, 1. Now, if you're not sure, like, what, how did that happen? You can also just pick a number for x, plug it in. It can be any number that you want, but we really want perfect squares inside the square root. Remember, perfect squares are like 1, 4, 9, 16, 25. All of those we could take the square root of. So if I put in for my x value a 1, well, that won't work. But I can make this inside part be a 1 by using x equals 5. So if x is 5, that would be 5 minus 4, which is 1. The square root of 1 is 1. So I could plot the point, x value of 5, y value of 1, or if you want to just put the coordinate in here, if x is 5, oops, not 45, 5, it outputs a 1. Square root of 1 is 1, and plot the point. Now I could plug in the next value that I see, which is 6, but 6 minus 4 is 2. It's not a perfect square. I need something that's going to make a perfect square. The next perfect square after the number 1 is going to be a 4. So if I could think about what could I plug in here, take 4 away, and make 4. Well, that would be an 8. 8, take away 4, gets you 4. And the square root of 4 is 2. So if I plug in an 8 to this function, it would pop out a 2. So I'd plot that point. And I still need 1 more. So that was getting a 4 inside. Now if I want the next perfect square, which is 9 inside, I need something that you could take 4 away from. And that would make 9. Well, that would be 13. One way to think about that is I want a 9, so let's add the 4 back to it. That would make 13. So if I put 13 in for x, and I'm going to plot my point here, 13. 13 minus 4 is 9. The square root of 9 is 3. So it's going to output a 3. And so that should look very familiar. It looks like that square root function shifted to the right 4 spaces. Now I'm going to click on the connect the dot thing and it'll just draw it for me. And so that's my square root function shifted to the right 4. And I can check it. Woo, got it right. Now if I want another one, let's try and find one that's slightly different. If you look at this guy, this time the minus 5 is outside of the function. So it's not going to affect the x that's inside. It's going to affect the output after taking a square root. So what that's really going to do is shift my entire graph down by 5. So again, inside this square root, I want to have perfect squares. Since there's no adding or subtracting inside the square root, I can just plug in perfect squares like 0. So if I plug a 0 in, the square root of 0 is 0, minus 5 is negative 5. So I'm going to have the point 0, negative 5. And this is going to be that leftmost point because the entire graph is only shifting down 5. So normally we're at 0, 0, shooting off. Now we're going to be down 5, shooting off. All right, we need some more points. Well, 1 is the next perfect square after 0, so we'll put a 1 in there. The square root of 1 is 1. 1 minus 5 is negative 4. So I'm going to have the point 1, comma, negative 4. Plot that point. The next perfect square I could plug in would be a 4. The square root of 4 is 2. 2 minus 5 is negative 3. So again, I plug in a 4 because that's a perfect square. The square root of 4 is 2. 2 subtract 5 is negative 3. So it's going to output negative 3. And you can see again that shape happening. Now I need one more point in here. So the next perfect square after 4 would be a 9. So the square root of 9 is 3. 3 take away 5 is negative 2. So I'm going to have, if you put in a 9, it's going to pop out a negative 2. Oops, I never plotted the last point. I took it out for some reason, so that was a 4, negative 3. All right, so I think that was correct. Let's connect the dots. You can see my square root on there now, or that square root function, and we'll check that we are correct. Woo, we did it. So again, it's really important with all of our functions to notice the parent function first, and then see where the next other numbers are that are making these newly transformed functions. If we are outside the function, you're going to be shifting up and down. If it's inside, right next to the x, it's going to be moving it left and right. I also wanted to remind you really quick, there's these other features on the right side here, so if you want some more help, there's videos you can watch. It takes you to the textbook connected with this, these problems. And then there's also a dictionary. You can click on the word function, it tells you what a function is. So just a few more resources on there. So hope that was helpful. Good luck studying.